Okay, I have started the recording. So we are at the end of the classes. Okay, it is almost the course of our topics will almost be completed in a matter of 5 to 6 days. So we are on class level typecasting. So this was a discussion happened in the previous session, isn't it? So now we know what is class level typecasting. It is like the process of converting data from one type to another type is called as typecasting. Right? So usually we know that there are two types of typecasting. One is primitive type. So we have discussed this already with respect to primitive data types, right? And second one is the user-defined data type casting in Java. So again, it is further classified into two types. One is upcasting and the second one is downcasting. In the last session, we have just started discussing about the upcasting. Right? Now we know we have got some idea about what is upcasting. Now we will see today we are going to see some used cases about upcasting. So where exactly we are going to use this upcasting topic, right? And what are the advantages that the concept has, the upcasting has, right? Why one has to go for this upcasting topic? So let me build a small class. For example, let us say that the paint screen. I'm going to take a class like animal class, right? So this is going to be the parent class for three children. Okay, one is a cat, second one is a dog, right? Third one is let us say something like right. So I have an animal class. I'm going to make it as a parent class. At this parent class, there are how many subclasses? There are three subclasses. So cat is one subclass, dog is another subclass, and lion is another subclass. So whenever you have a kind of a common requirement. For example, if you look at this hierarchy, so when I say animal, I am not being very specific, isn't it? There are n number of animals, right? The animals are, even though they are countable, there are many animals, right? Cat is one among them, dog is one among them, and lion is one among them. Right? If you have any kind of the common properties, right? When I say common properties, so when you just expose the data in the form of classes. When you take animal class, the class is every class is going to have properties and methods, right? So we have properties. Properties are going to store a kind of data, and you have methods for the business operations. So the common properties will always be placed inside the parent class, right? And the common behaviors or the common methods will always be placed inside the parent class, right? When you talk about the specificity, right? So this is common properties. And don't get any confused. When I say properties, properties are nothing but the variables. Okay, they are also called as attributes. Okay, the data that you are going to consider. Okay, the data that you are going to talk about, the variables that you are going to talk about, they come under properties. Methods, they are also called as behaviors. So the business logics that you are going to write. Behaviors. So the common properties and the common methods or behaviors will be taken inside the parent class always, right? And if there is any specific property, so you come across there is a specific property, specific always a specific property for a subclass or the in this example the cat class, right? So cat does something which dog cannot do, or lion does something which dog and cat cannot do, right? So those are the specific properties that are specific to the subclasses. So you take those properties and you take those the behaviors under the subclasses, specific properties and the behaviors, specific properties and the behaviors, right? Specific properties and the behaviors. So this is how the hierarchy is going to be, right? If you want to design a class, very simple, right? You take an animal class, you take a class, animal class, and let us say that inside the animal class, the property can be, right? You can define a name, okay? The name of the animal, common for all the subclasses. Cat has a name, right? Dog has a name, and lion has a name. right? And the second one is the property. Another property can be the weight of each and every animal, which is going to be, like, they can fit in this variable, right? Even cat has a weight, a dog has a weight, and lion has a weight. Okay, so they are not specific, they are common to all the animals, they are common to all the subclasses. If you identify, if you are able to identify such properties, you would take that under the or inside the parent class, right? So let us talk about the methods, let us talk about the behaviors, a kind of behaviors like, okay, I can say that now the common behavior can be, right, avoid, make noise. Okay, so making noise is common, but how the noise is being made is specific. So making noise is always common, right? Every animal make noise, right? Every animal make noise, it is common, but how the noise is going to be produced, that is going to be specific. Here I am talking about the common property, right? Make noise common, every animal makes noise. Every animal is going to do what? Every animal is going to make noise. So what are the behaviors that I can take? Okay, avoid, walk, not walk, let me say avoid, chase. Every animal chases, right? When cat chases seeing rat, dog chases seeing cat, lion chases whatever it sees. Every animal, this can be common for all the animals, could be common for all animals. So these two behaviors I can say. And again, if you look at this make noise, the cat would make noise in its own way, dog would make noise in its own way, lion would make noise in its own way. So this is how I have developed the parent class. This is how I can develop my parent class. Now what I'm going to do, let us bring this here. Let us bring this here. Now let us develop what? Let us develop the child classes. So child classes can be like, so what is the one of the child classes that we are discussing about? So you have what? Increase the font size. You have, cat, right? So if you extend this cat to animal, if you extend this cat to animal, right? See, just try to focus here. You are just extending the cat class to animal class. What does it really mean? This all the properties, okay, all the properties and all the behaviors are available for the cat class also. All the properties and all the behaviors of the animal class is available to the cat class also. So the cat class can comfortably use the properties as well as it can use the methods, right? Let us say that animal, see, cat is going to make a noise in a specific way, right? So it does not want to depend upon the make noise method of animal class, because cat is going to make a noise, or cat is going to do what? Cat is going to give blow the sound in a different way. Class is going to speak in a different way. How is it? I can say void make noise, right? So system dot out dot println and cat is meow meow. It is very specific to cat, right? If the child class does not like the parent class implementation, right? If you feel that child class behavior is something different than the parent class behavior, no matter, right? Even the, if there is any common similarities, like, this make noise method is common for animal, right? And it is specific for cat, specific for, if you find any specific things, you, the child class has an option to have its own implementation, right? So behavior changes. Cat makes noise in a different way. So what you have done, okay, if you just focus here, so you have used the method name as make noise method, right? And here the method name is also make noise method. Both methods are identical, both methods are similar, right? What does it really mean when you are using the same method which is present in the parent class? That concept is called as what? The overriding. So this is called as the override method. Okay, the method that is used for override is called as what? This method is going to be right, the overridden method. Overridden method. Right? Likewise, see we will develop this code. Just try to understand this in different way. Let us take that you have the dog class. Dog also extends to animal because animal is going to be the common class for the dog as well. And when you dog makes noise in a different way, right? How does a dog make noise? So dog says bow bow or wow wow, whatever it is. Right? It has its own specific implementation. It does not want to depend upon the parent class implementation. Now this method is called as what? Technically they are called as, this method is called as the override method. We will see the advantages of the override method at the time of object creation. For now, this is called as override method and this is called as overridden method. Right? Likewise, if you say something like, the animal is also extending what? Animal is also uh, extends to the line is also getting extended to the animal class, right? And the lion has own specific implementation, make noise, right? So lion has a different sound, isn't it? So lion, it always says or, right? And this method is found to be what? This method is called as the override. That okay, the method that is used for override is called as override method. Right? Now, in the main method, you are trying to create an object. For example, the object can be created in three different ways. So let me put you in this way. Focus here. Okay, you have the let's say that okay, you have the parent class, right? You have the animal as a parent, and let me see. Pen is not working. So animal as a parent, and you have dog class as a subclass, you have cat class, and you have lion class. And if you look at this hierarchy, this is called as what? This is the hierarchical inheritance. So one parent has three children. One parent has three children. Now let us understand what happens if you create an object. You can create an object in how many ways? There are many ways that you can create an object. You can say animal A equal to new animal. Okay? The moment you start saying animal equal to new animal, the new keyword is being used for the animal class, which means object is getting created for the animal class, and the reference is also animal. If you create an object like this, right, you have, okay, this variable A can access, this variable A has rights to access, it has some rights, okay, to access. It can access the name property, it can access the weight property, can access the make noise method, it can access the chase method. So it has access to all the methods. So likewise, the moment you start creating an object for the cat class, cat equal to new cat. Here the reference variable is C. So with the help of C reference variable, now you try to understand, okay, with the help of C reference variable, you can directly access what? You can access the make noise method. You might be getting confused, okay? So since the make noise method is part of the child class, okay, this is the child class, name of the method is make noise, this part of the child class, and also you are able to see the make noise method in the parent class as well. right? Firstly, the priority will be given for the child class. Child class make noise method will be given the priority because you are using the C is of what type? C is of the cat type. So firstly, the make noise well method will be identified whether it is there or not inside the cat class. If it is not there, then it will jump to the parent class, which is animal. Right? Likewise, this C reference variable has access to the chase method of the parent class. Okay, so when you call something like the chase method, for example, when you say C dot chase, okay, the control will try to identify for the chase method inside the cat class. There is no chase method here, and it will make use of the extends keyword, and it will go to the parent class, which is animal. Then it will go to the animal class. It will try to find for the chase method. The chase method has been found. It means access has been granted. It can able to access. Likewise, firstly the searching will happen for the searching will happen inside the child, the subclass. Then the searching will happen inside the. If it is not there in the subclass, then it will try to find in the parent class. And the question here is these two are completely accepted, right? But so we are trying to create an object like this. Okay, for example, let me say that object is being created like animal, a or animal obj equal to new cat. So here this is where you are getting the confusion, isn't it? Animal obj equal to new cat. Right? So when you see animal, where is animal? So this is animal. Animal is of what type? Animal is of parent type. When you say cat, where is cat? This is the cat. Cat is of what? Child type. You are creating an object for the child class. Object is created for the child class, but you are using the reference of the parent class. Right? If you see, object is being created for the child class. New cat is the thing that you have written. New cat. Object is created for the cat class. Right? But when you look at the reference, okay, when you look at the reference variable, right, the reference of what type? Reference is of the animal type. Okay, you are storing this in the animal reference variable. Right? So the question is, with the help of obj, what are the things that we can access? Okay, let me write here. Obj. So when I say obj, the first thing you can access all the methods of the parent class, all the methods and the properties properties of the parent class. But if any method found to be overridden, if any method found to be overridden, then the respective override method will be called. Example, if I call when I say obj dot chase, there is no confusion here. This obj is of what type? Obj is of, okay, look at here, obj is of what type? It is of animal type, right? So it is going to check for the chase method inside the animal class directory. Okay, chase method is found. Okay, so access is granted. Okay, chase method access is granted. Okay, now this will get executed. No confusion here. The chase method will get executed. The moment you write obj dot make noise, okay, make noise. Okay, again obj is of what type? Obj is of animal type, right? Okay, the control will be traversed to the make noise of animal method. Okay, make noise method is here, but this method is overridden method. Okay. it will look for the respective override method. This overridden, what is the respective override method? So this is the respective override method. This will be called. This is the only difference. For example, when I say obj dot, if there is any other specific method inside the cat class. For example, let us say that the cat class has another method like void m1 method, right? And when I call m1 here, obj dot m1, and even though the object is created for the cat class, even though when you see the object creation has happened for the cat class, right? But the reference is for animal. So this m1 method will be, the control is going to check for the m1 method inside the animal class. It will never go to the cat class. It will never go to the cat class, because that is not what we have defined. So we have defined, okay. So this is what the takeaway is. So the restrictions will happen for all the methods inside the child class if it is not overriding. You may have n number of methods in the child class, okay, and if the reference is parent, right, you cannot call any child class methods if it is not overridden. That is a takeaway. We'll see this programmatically. Okay. So let me take a simple class. Okay, source. Right click here. It's taking some time. Give me a minute. Huh? Let me use notepad only. Yeah? This is irritating, guys. This Eclipse is irritating. For a while. Let me take directly class, animal class. Okay, inside the animal class, let me just take the methods. Okay, void make noise method. Dot out dot println. Second method is I'm taking void chase method. So the chase method, I'm going to write a simple line here. Okay, this is going to just print. Okay, so this is not a great business logic. So we are trying to understand the control flow, right? Whenever the chase method or the make noise method is called, so you will get to know whether it is getting called or not because of this print statement. Apart from that, nothing here. So no rocket science here. But chase method, email every animal. So this is a simple animal class I have taken, right? Let me quickly take the cat class a cat. So now you see I am trying to copy and paste the same method, but here I am just changing the logic. So this is going to extend, right? This is going to extend to is extending to animal. Animal is going to be a parent, right? Why? Let me take a dog class. Dog class is also extending to animal. Right? Dog says blah blah blah. Let me take another animal. Lion. Lion is also a lion. Lion just told sound. Right. So you have how many classes totally? You have animal class, first thing. Okay. And there are three children for animal. One is cat is one among them, dog is one among them, and lion. Right. After that, I am taking the main method. Right. The main method is going to be public class driver. Okay. Public static void name string array object. Now let me create an object for the animal class. Animal A equal to new. Okay. Let us compile this first. Don't open command prompt also. Let me change the drive. CD space Java. Okay. Let me save this file. Save as. Let me choose the workspace D. Got it. Driver dot. Main class name I am using. My main class name is public class driver. I am using that name because it has the main method. Driver dot Java. Let us compile this. Java C space driver dot Java. Not sure how many errors we are going to get. Okay, it has been compiled successfully. Okay, let me run this as well. Java space. So output is going to be empty because in the main method only we have created an object for the animal. Now focus here. The object is created for the parent class and the reference is also the parent class, right? So with this I am able to call what? I am able to call both the methods, make noise method and chase method. Let me call make noise. Okay, a dot chase. Right? Now let us see. You say blah 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 and every animal chases, right? So only I am able to call all the methods inside the animal class. So these are there are two methods, I am able to call those two methods, right? But the moment I start using the child references, when I say new animal cat, okay, animal A equal to new cat. Okay? So this is the reference variable A. A is of what type? Animal type. And also remember the object is created for the cat class, but you are assigning the object creation to the animal reference. Reference is used as the parent, but the object is created for the child class. So this is a reference variable. So this reference variable is little confusing because type is animal, but object is for cat. It's like I can just say like parent reference child object, right? And this is the reference variable. With the help of A, okay, if I ever want to call the chase method, I can call. No issues. Every animal changes, right? The moment I start calling the make noise method, right? So make noise method is part of animal class. You see, a dot make noise is part of which class? Animal class. Right? But remember that the object is created for the child. Okay? The moment you call the make noise method, the control will be traversed to call the make noise method of animal class. It will check. Okay, if the child class, here the child class that I am talking about is the cat class is child class. If the child class has the same method prototype or not, of course the child class has the same method prototype. Both are same. The priority will be transferred to call the make noise method of the child class. This is the takeaway here. Because this method is the override method, which is the override. Priority will be given to call it. So you should get the output as meow meow. Right? So when I say, so when I execute this, so meow meow. Likewise, when I just change from cat to dog, the runtime, okay, now I should get the make noise method of the dog class. See, dog is blah blah. Huh? Dog should wow wow, right? Java C space driver dot Java, Java space over. So I just try to make okay in the runtime. I'm just changing the objects. That's it. Just replacing this object. The respective methods are called. Like, right? So with the help of parent reference, I can able to call all the children classes, the specific methods, right? I am just changing the what we call it as the classes here. Okay, new lion. When I say new lion, the make noise of lion is getting called. When I say new dog, the make noise method of cat is we have that control. That is an advantage here. We have that control. You can pass anything in the runtime. You don't like if you want to call the make noise method of dog, you have that control here. You can just change here. If you want to call the make noise method of cat class, you can just change here. With the one object, you have an option to call the with the one reference variable of the parent class, you have an option to call all the specific methods of the children class or the child classes. Right? But now you see, so inside the cat class, I'm saying I am taking another method, void m1. Okay, it's a random method, right? A random m1 means something like a random method. Okay, let me say random or the cat class method. I cannot call this, so I am placing a restriction. This is also keeps a restriction. When I create an object for cat and when I assign the I'm sorry, when I create an object class and when I assign it to the parent class reference variable, I can call make noise method, no issues, but I cannot call the what I cannot call this m1 method, which is also part of cat class. That is the restriction. M1 method cannot be called. When I call this, I will get an error. It cannot find symbol a dot m1. It's not able to identify. The takeaway is the specific method. Okay, when the object is created like this, parent reference and the child class object. Okay, the specific method of child class cannot be called. And be called. But common methods can, but the common methods or the override methods can be called. Called and all the parent class methods can also be called. That is the takeaway. Okay, let me take a different example. Now see the beauty of this upcasting. Okay, I have a main method. I am also taking another method, and the method is static method, and I am taking it as void, right? So the static method is accepting the animal as a type, animal as a parameter. Starting is method is accepting what animal object as the parameter, right? So what I'm trying to do here is I'm just saying a dot make noise. Method name is type is static, and the return type is void, and the name of the method is the type itself. I'm taking the name of the method as type. So this method is accepting the animal as the argument, animal object as the argument. In the runtime, okay, now you see, if I just pass, if I just say a obj animal a equal to new animal, if I call this type method, I pass a, I call the type method. This is a static method. I do not want to create an object. Just call this type method, and I can pass this reference variable. This reference variable is a. Object is created for what? New animal, right? Now, which make noise method will be called? Blah blah blah. Animal make noise method is getting called. Likewise, if I just pass the runtime, if I just pass cat, now which make noise method will be called? Cat class make noise method will be called meow meow. In the runtime, if I pass dog, I just pass dog. Okay, which animal method will be called? Which make noise method will be called? Dog class make noise method will be called over. If I pass lion, which make noise method will be called? I have that control. Okay, I have identified many make noise methods. I want to call the specific make noise method of a particular subclass. That means my requirement. Simply I can do the upcasting. I can perform this kind of operation. I can able to see what logic is there inside the make noise of each and every subclass. That is a takeaway here. Let me just let us trace this only this part. Okay, now you focus here. Let me remove it. Okay, I have an object for new lion. Let us imagine that you have an object for new lion. You have an object for dog. Okay, and you have an object for cat. Okay, and you have an object for the animal. Right, and there is a separate method. Okay, for the demonstration purpose, I have taken this method. This method is not a special method. This method is helping us to understand what is the upcasting concept. That's it. So I have taken the return type as void. Okay, this is the name of the method, which is the type. It is accepting an argument of what type? Animal type itself. It is accepting the argument of animal type. Right, and no, you are using the variable a variable, right? You are by using this reference variable a, you are accepting animal object by using this reference variable. You are just calling the make noise method. You're just calling the make noise method. Okay. Now you see in the runtime, if you pass new animal, right? New animal is a reference for what? New animal is an object with the reference variable a. Right, so this new animal object will be transmitted, okay, to there, right, and it will extract, okay, it will extract the make noise method of animal class here. There is a logic in the animal class. So what is the logic of make noise method? Blah blah blah. This method will be called. You are being very specific here. You are being very specific. Since you are passing the object of the parent class itself, the parent class make noise method will be called. Likewise, in the runtime, okay, if you do not like to call the parent, if you want to understand, you want to execute the logic of each and every children, okay. Let us say if you want to execute, if you are passing new line, this new line will be argument to the variable a, which is of animal type, right? And you are passing, you are calling the type method, right? So type method is accepting the new line as an argument. Okay? So this is going to extract, okay, this is going to extract the make noise method of make noise method, which is inside the lion class. Okay, now you get what if you pass new lion as an object, you get an object as a new line, and if you pass it as a reference for animal, the make noise method of lion class will get executed, right? If you want to call new dog, the make noise method of new dog, I mean the dog class will be executed. If you pass new cat, the make noise method of new cat method gets executed. All you have that control. I'm saying you have that control, right? So this is the parent class, and all these things are the child class, right? But even the parent class also the make noise method. Every child classes make noise method, make noise method, make noise method. Okay, but the reference variable that you are using is animal is the reference variable. Some variable name like animal, right? If you map this animal A to new animal, okay, the make noise method of animal class will be called. If you map this animal to the new cat, the make noise method of cat class will be called. If you map this animal to the new dog, the make noise method of dog class will be called. If you map this to the new lion, the make noise method of lion will be called. So you're using the parent reference to call all the common methods of subclasses as well as the parent classes. That is the idea. The future, okay. So this logic, this my demonstration is applicable only to understand the control flow. Okay, in the major applications, the logic would be like there will be a payment type, and you will get an options to choose the banks. Okay, you can choose, you can make the payment by using Axis Bank, you can make the payment by using HDFC Bank, okay? You can make the payment by using what, by using the Canara Bank. Okay, so inside the payment type, okay, method, there is going to be a common inside the payment type class, there is going to be a common logic like a kind of balance, right? And you will be having the balance okay, let us say that you have 3 bank accounts, okay? You will be having balance in the Axis Bank, and likewise you will be having the balance in HDFC Bank. You will also be having the balance in the the Canara Bank, right? So balance, some logic is there to display the balance. Okay, when you call this method, you will get to know the balance. Okay, let us say that the payment type is something like the phone pay as the payment. You have an option, right? So multiple accounts can be linked to one phone pay account, right? If you fetch the balance, so now I can say that your phone pay parent type, and by creating an object for the Axis Bank, right, you can fetch balance, you can say p dot balance. Now balance of the Axis Bank will be displayed, so you get the actual balance that is there in the Axis Bank. The moment you say not Axis Bank, when you say HDFC Bank, see, the method names are common. The actual idea is you want to fetch the balance, right, which is common, right, which is very, which is very specific for each and every bank account. You want to fetch the balance of HDFC Bank. This is you just change HDFC here. You create an object for HDFC, and the actual parent is going to be phone pay. Right, now the HDFC balance will be displayed. Right, now when you say Canara Bank, the Canara Bank balance will be displayed. Similarities are there, right? You are identifying some common similarities, common features. Right, so this is the a kind of high level understanding about the upcasting, but this is not the way that you're going to implement, but this is the idea behind the scenes. Common methods, how to pay, how to, how to call the respective common methods under one parent class. Okay, for now, okay, if you are not getting it again, okay, I will tell you only one thing. Okay, just try to practice this. Just to type and practice, type and type. Please type in the laptop, by yourself, and try to execute this code. Okay, you get some errors, fix that errors. If you don't understand these things, get back to me. You will understand what happens. You will understand the control flow only when you type. When you listen to me, you just listen to the lecture and you just listen. You will get some theory, right? Sometimes the lecture might not get understood perfectly until and unless you practice this thing. If you practice this thing, the next classes are going to be very much interesting. Not going to be like the way that the class you're going. See, you have to put some efforts, guys. Apart from that, nothing. Without efforts from your side, if you feel like, okay, this is not understandable, that's not understandable, that is not how we can learn subject. Some efforts are mandatory from your side, and with the efforts, the topics will be interesting. Okay, and you will feel like to join the next classes in an enthusiastic way. If not, it will be like a dull topic, a boring topic. Listening and without practicing the laptop will not get you anything. Okay? Right? I have plans to take at least 5 to 6 mock interviews for each and every one of you. Only I can take only if you have interest. Okay, I did not started the project itself. Understand these things, then the project is going to be very easy. Any questions for me?